Hello and welcome to Programming with Python Lesson 2. Today we're going to look at variables, we're going to look at performing maths, and maybe one or two other things, you lucky people. So let's start by going through the idea of variables in a little bit more detail than we did last time, because variables are one of the most powerful features of any programming language. So simply put, a variable is a name that refers to a value. And that's a value stored somewhere in the memory of the computer that we can locate and use and change the value of time and time again. We use assignment statements to create variables and give them values. So if you have a look here, we've got two examples. We have message equals what's up doc and number equals 17. So if you look closely, we've got the equal sign here in the middle, and we're not using that for equality or some kind of mathematical meaning. We're using it to mean whatever's on this side goes into here, and whatever's on this side goes into here. So what we're doing is we are creating kind of like a box somewhere in the computer's memory, and we're adding a value into that box. That box has a label. Every time we refer to that label, the computer knows which memory location to go to and takes that value out and uses it. So a variable, as the name suggests, is literally something that can vary. It can change. It could be a number, it could be some text, or one of the many of the data types we haven't met yet. All variables must have a name. We've got to give that memory location a name so that we can refer to it time and time again. So you could use something very simple like x or n. X equals 7, n equals 3. And that's all you need. Very simple. So we've got a memory location somewhere. We're going to call it x. And inside that, we're going to store the value 7. Now, giving really short names like x and n probably isn't a good idea because it'll be difficult to remember what they mean when you come back to the program, but it could be as simple as that, just to create a variable and store a value inside it. If we look at this diagram, again, just to illustrate the point, we've got a equals 5 here. So somewhere one of these memory locations, for example here, now has the label a. And in it, we're going to place the value 5. So every time we say A, the computer goes along, looks through the memory locations. Aha! This is label A. So in this memory location, we have the value 5. And this is what I'm going to use in the program that's running. So of course, this is a simplification. But if you just think about the variable as giving the name to a memory location in your RAM and then storing a value in it. And as you're running the program, you could change that value if you wanted to, because it's a variable. It's not a constant, it's not fixed. When we store data as a variable, the computer needs to know what kind of data it's going to be. So for example, in that memory location, in this variable, are we going to store text or a number? Or perhaps something more exotic? And this is to save space, to speed up calculations, for data validation. There's lots of good reasons that the computer needs to know what the data type is. And there are lots of different data types we can deal with in any programming language, including Python. But we're going to look at just 5 just now, just to get us started. And these are the 5 that we're going to use most often. So first of all, we've got string. String is really just a computer speak for text. So it means a string of characters. So hello, goodbye, something like that is an example of a string. Floating point numbers. Sometimes we just call them floats for short. So this is anything where we've got a decimal place in it. So 2.4, 6.0, minus 89.54, they're all floating point. Integer. We should know what integer is. It's a whole number. Often we just say int for short because it's nice and quick. So whole number, no decimal places, 2, 6, minus 89, etc. Be careful. 6 is a floating point. 6 is an integer. Even though it's 0.0 for the floating point, It still has a decimal place. It's still a floating point. The computer will handle 6.0 different than it will handle 6. So be careful with that. Booleans are very useful. A Boolean is either true or false. It's a binary choice. So you've got something like male equals true. Make sure you use a capital letter in Python when you're assigning a Boolean value. We'll use these a lot later. Long. Long is just like a really big integer value. So I think integers go up to about 2.14 billion or minus 2.14 billion. If you want a bigger number, you need to use long because that can store really, really big numbers greater than 2 billion. So again, here's a quick table just showing you that. We've got floats, for example, 3.14, any value with a fraction. Long for really, really big numbers like 10 to the power of 100. So greater than this number, which is 2.147 billion. Integer, for example, 42, anything less than 2.14 billion. We've got booleans, which are true or false, and these are really good when we're doing comparisons. We've got things like equals to, not equals to, greater than, less than, etc. But we'll look at that more detail later. So let's have a look at data types. Let's look at how they're used. So when we get user input, Python automatically stores it as a string, as text. This can cause problems. So if we look at the following code here, looks pretty simple. num_a equals input, input a number. num_b equals input, input another number. So what we're doing is we're taking a value from the user and we're just storing it inside these variables, num_a and num_b. So whatever you type in is stored as num_a, and then whatever you type in for the second number is stored as num_b. And then we're doing a little bit of math. Answer equals num_a plus num_b. So add these two together and then store the answer as answer. And then finally print the answer and display it on screen. Now, superficially we'll look at this and say if I typed in 3 and 4, it should come up with 7. But when we run it, it comes up with this. I've typed in 3, I've typed in 4, it comes up with 34. And that's because it thinks num_a and num_b are text. So when we have the plus here, the computer doesn't think add them together, it just places them next to each other. 3, 4 together. So answer is just 3 and 4, and it's text as well. So when we print it on screen, we get text. What we need to do is cast or convert the input so that Python knows that it's a number. So we have to be specific here. Usually we don't with Python. Python's quite good at guessing what we want, but when you're dealing with user input, if it's not going to be text, we need to convert it. And usually we convert it straight away. So there was an example of that in the previous lesson. And you see here, what we're doing is we're converting it to an int as soon as we input the number. So if we have a look at this process, it's going to display on screen input a number, and then this value is going to be converted into an integer, and then it's going to be stored as num_a. And the same here. Display on screen input another number. Whatever is input will be converted to an integer, and then that will be stored as num_b. So now when we run the program, we've got two numbers. So for example, if I type in 3 and 4, it'll add them together and store the answer in answer as the integer value 7, and that's what should be printed out. So again, I've entered 3, I've entered 4, and this time I get the correct answer. So when we're converting, remember it's the type that you're converting it to. We have an opening brackets and a close brackets. What type of data are we converting it into? Open brackets, closing brackets. We could try and convert it when we're doing the math. We could have used int num_a and int num_b here instead. But usually it's best to convert it straight away. And that way we don't have to worry about forgetting later when we write long programs. So if you want to input a string, you just input as normal. It'll be automatically set as text. If you want to input an integer, start with int before the input. If you want to use a floating point number, use float. Long, use long. Just don't forget you need this extra set of brackets at the opening and the closing. I often tend to forget the final closing brackets, but then I am quite forgetful. Hopefully you'll do better than me. Next, we'll take a look at the math operators. Clearly, if we want to do maths, we have to use the right symbols to do the maths. So some of those are pretty obvious. Plus, minus, obviously, there we go. That's all pretty simple. For other types of math operators, though, you might have to use different symbols than the ones that you're familiar with. So to do multiplication, we use the asterisk or the star sign. Division, we're using a slash. And then we've got some other ones here. So this is when we want to raise one number by the power of another number. So the example is A star star B will give 10 to the power of 20. So if I wanted to do 5 to the power of 10, I would write 5 and then star star 10, and that would be the equivalent of 5 to the power 10. If you can read my writing, of course, that looks kind of like a 16, but it's really a 10, honestly. If we take it the other two now, this is modulus, often just called mod for short. And what this does is it divides one number by the other and gives you the remainder, not the answer. So, for example, if I were to write, 10 mod 3, that would give me 1, because 10 modulus 3 is remainder 1. It's 3 remainder 1, so modulus or mod just gives you the remainder. We also have this one, which is floor division. Basically, it tells you how many of one number you can put into another number. So, for example, here we've got 9 div 2. Sometimes we call floor division just div for short. 9 div 2 is equal to 4. There we go. Because you get 4 2s in 9, and it ignores the remainder. If I take the same example I was using before, if I say 10 div 3, it will return 3. So if you want to get how many times one number appears in the other, we can use floor division or div. If you want to get the remainder after you divide two numbers, we can use modulus. So we'll practice using those a little bit later because they can give you some interesting results. Another thing we have to think about is the order of precedence. Again, just like when you're doing maths in your math class, you've got to be clear about the order of precedence. Otherwise, if you're doing a series of calculations in one line, you might not give the answer that you expect. So take a look at this and just kind of make sure you know roughly what the order is. Again, you can use brackets to write down the formula, to break it down, if you just want to make clear which bits go first. Let's do some activities now. So I'll kind of tell you what the instruction is, what the task is, give you some code to get started, and you can pause it and have a go at writing this code. So we want to write a program to input 4 numbers, add them together, and print out the answer on screen. So most of the code is here for you. We just need to complete part of this line and add all of this line. So if you look at number 1 and number 2 lines, that should really tell you what you want to do here and here. While you're working on that, it's probably a good time to start talking about variable names. Don't think I've covered that just yet. If you can see how we are using variable names here, you'll notice you can't have any spaces in the variable name. So it's not number space 1, it's number 1 together without a space. You could have an underscore if you wanted to join them together. Kind of like number underscore 1. But you can't use a dash. So number dash or hyphen 1 doesn't work. It'll think you're trying to do math. It'll see number minus 1. So number underscore 1 is okay, or just number 1 together, no space. In my particular computer science department, our house style is to capitalize all the variables. That's not something you have to do. Different departments, different companies, different universities will have different styles of how they want you to name the variables. I'm generally going to use capital letters because that's just the house style where I work. But if you want to use lowercase n for number 1, number 2, number 3, that's okay. It's just generally better to be consistent, pick a style, and keep with it. Okay, we got all that solved. We worked it out. Let's look at the solution. So hopefully we worked out how to do the input for this. Again, we just need to do the third number. The rest of it's the same. And then number 4, and then int input, enter the 4th number. And when you run this, it'll let you add 4 numbers together and give you an answer. Okay, so again, make any notes, change anything you need to. The next activity is very similar. It's a program that does exactly the same, except instead of being an int value, an integer, let's experiment with floating point numbers. So remember, if you want to cast it, instead of using int, we're going to use float. So again, the code will be very similar. You can copy and paste or just change your old program. Just change int to float, run it, see what happens. Have you done that? Hope you have, because I'm going to show you the answer. So as you can see, it is exactly the same, except we're using float here. Divide it, and it'll be fairly similar, except of course, your average here, you'll still have a floating point number rather than an integer. Okay, that was fairly basic. If you can handle all that, that's great. These extension tasks are just a little bit of extra practice if you want to go through and try something a bit more difficult. Extension 1, write a program that takes the price of an item as input and works out the VAT, 20% due, and the price before VAT. So for example, if I input the price was 100, it should display that the VAT is 20, because 20% of 100 is 20, and that the price before VAT should be 80. So it should say something like VAT is 20, and the before price is 80. So you want to display something like that, some text and a number. So remember, because you're inputting a price, for example, $9.99, because you've got this decimal place in the fraction part, you need to remember to create it as a float, not an integer. Otherwise, you might have some problems later on. Ready for the solution? Really? You did work on it, didn't you? Okay, well, let's take a look. So I'm saying cost equals float, input, enter an amount of money. Again, we'll enter the amount of money, convert it to a floating point, store it as cost. VAT is just the cost multiplied by 0.2. That's a kind of shortcut that gives you 20% of something. You could, for example, also divide by 100 and then multiply by 20. That would work as well. Other ways you could do it. Original cost equals cost minus VAT. So whatever the original cost was minus the VAT that we've just calculated. Then we're going to say print VAT equals £, comma VAT. So that should print out some text plus whatever is in this variable. And then print original cost equals £, comma, and then original cost. So again, it'll print out the text and then whatever's held in this variable in the memory. So this will work pretty well, but you will get something slightly strange in the final answer. You might have experienced this before when we're using floating point numbers, but I think you definitely will see something here as a result of the division. The problem is your answer isn't formatted to make sure it's kind of in the strict format of a number when we're using UK currency. So in UK currency, we're always going to have a number to 2 decimal places, yeah? So if you might end up with something going 901 or something weird like that that you don't want. We always want the final answer to be to 2 decimal places. So to do that, here's some code that you can change and add to the original program. So we're using the dot format method. What this part of the code here does is just specify that it's to 2 decimal places. So you can look for string formatting in Python, do a Google search. There's lots of web pages about it. This just means 2 decimal places, and we're going to format to 2 decimal places whatever number is in the brackets. And then the same thing over here with the original cost. we're going to format it to 2 decimal places, add it into the string. So if you add this extra code, you will get it nicely formatted to 2 decimal places. There's lots of ways you can format text. Well worth doing a Google search if you're interested in learning more. So extension 2, write a program to work out x to the power y. Remember, the operator star star or asterisk asterisk is used to work out powers. So take in 2 numbers, work out one as the power of the other, display the answer. Got it? Let's check the answer. Dun, 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 dun. Okay, so number equals int, input a number, exponent equals int, enter an exponent. Answer equals number star star exponent. So for example, if I entered in 3 and 4, it would give me 3 to the power of 4, and then print the answer out. So again, the only thing you have to worry about here is making sure you're using the right symbol here, so the computer raises 1 to the power of the other. Number 3, okay, this is going to be a little bit more complicated. You might not be able to work this one out. If you can't, don't worry. Again, this is for more advanced students. Write a program to take an integer number of minutes as input and work out how many hours and minutes there are. For example, 1024 minutes equals 17 hours and 4 minutes. You'll have to use the div operator to work out the hours and the percentage operator to work out the minutes remaining. So remember, 47 div 5 equals 9 because 5 goes into 47 9 times. Remember, 47 mod 5 is 2 because 47 divided by 9 is 2 with a remainder of 2. So basically you need to take divs and mods and divs and mods and try and get out the number of hours and the number of minutes. Off you go. Wasn't that easy? Or maybe not. Maybe it was really hard. Should I go through the solution with you? Yeah, why not? Okay. It's not too difficult. Total equals int. Input, enter the number of minutes. So just add, work out the number, get the number of minutes, store it as total. And then the hours, it's total div 60. So I'll tell you how many times 60 goes into the total number of minutes, which is the same as the number of hours, of course. So whatever the result of this calculation will be stored as hours. And then we can say for the minutes, it's the total mod 60, modulus 60. So again, dividing by 60 and then giving you the remaining, which is of course the number of minutes. And then we can print it out. Hours, comma, hours and mins, minutes. So if you just look at the string input, just to make sure you get that right, because easy to mess that up, it's kind of divide it into sections. So we've got kind of section, oops, no, don't want that, section 1, section 2, section 3, section 4. That didn't quite come out. So we got kind of part 1, part 2, part 3, part 4. And we're just separating these just now with commas. I'll explain that in the next video, kind of why we're doing that and alternative ways of doing it. But just now we're separating it with commas. So we've got a variable. So whatever is in this variable will get printed. And then this is text, hours and. We're going to print exactly what's between the inverted commas. We've got another comma to separate it, another variable. So again, it's not going to print minutes. It'll print whatever is stored as the minutes value. And then we're going to join that together with minutes. Again, this is what we call a string again, because it'll print out exactly what's on here. So this section and this section, it'll print out just exactly what's between the inverted commas. And then this section and this section, it'll print whatever is contained in the variable in memory. So whatever number that you've calculated here and here. And again, we are joining it together using commas. So don't forget, it's an easy mistake to make. People forget to join each of these sections together. So you need 1, 2, 3 commas to join these 4 sections together. Okay, you could think about extending that. Maybe it could work out the number of days or weeks or months or years. I'll leave you to worry about that. And I will see you shortly in the next video. Good luck with your studies. Python is awesome.